All right, wonderful. Good afternoon, everybody. Welcome back. Ajanai, nice to see you. Kadia, missed the morning session. That's okay. I was having some issues getting the recording downloaded, but I think I should be okay. All right. Usual suspects are here. Body's back. All right, good. We're going to pick up from where we left off. So we had completed questions 1, 2, 3, and we did vectors and matrices. So we're going to wrap up the back of the paper. We're going to wrap up the back of the paper. I'm going to move to we're going to be moving to trigonometry and geometry. All right. So as soon as the recording is available for those who missed out on the actual session, you can get access to that. I'm trying to see if I can get it uploaded ASAP, but take some time. Taking some time, guys. As soon as it's ready, I will let you guys know. All right, ready? We are going to question number 9. All right. Quite interesting. Look at this. If them send transformation at question 9. What a surprise. What a surprise. So where is the triangle and the trig and the sine and the cosine rule? What does this mean for us, ladies and gentlemen? Are they trying to send us a message? Are they giving us a hint as to how the exam in next year is going to look? I've never seen this before. We've never seen this before. Them said this is trigonometry and geometry, but I'm seeing some sort of transformation going on here. So what's the formula you always give for the area of a triangle? Yes, AB times the sine of theta divided by, AB sine theta divided by 2. Alicia.
So did you say 360?
No, you say area of triangle, right?
Yes, sir.
AB sine theta divided by 2.
Okay, thanks, sir.
Okay. All right, let's get into it, guys. Question number 9, geometry and trigonometry. Jaden, you're here. Simara.
Sir.
Jaden. All right. Anyways, let's get into it, guys. Saf, your mic is unmuted.
Sorry.
Okay. All right. So the diagram below shows quadrilaterals O, M, and N. Quadrilaterals M and N are image of quadrilaterals O. Come again. I read too fast. The diagram below shows quadrilaterals O. Where that day? Oh, that one here. Let me just identify it first. O. All right. Quadrilaterals M. A big one here. And quadrilateral N. This one over here. All right. What does it say now? Quadrilaterals M and N are image of O. Oh, so that means that the red one are the object. So this is the object. And then these two over here are images. All right, cool. Me understand that part. After it undergoes 2 different transformations. So you have to figure out what caused O to become M and what caused O to become N. That we're going to try to figure out. All right, no problem. Understand that so far? Describe fully the single transformation that maps triangle O onto M. Talk to me, guys. What do you think?
Translation.
I'm not hearing Samara. You said what?
Translation.
Translation. So translation makes something get bigger. Correct.
Sir,
Ali?
enlargement.
It is a positive enlargement. That is correct.
Oh, I wasn't even looking at that.
So it is a positive. Britannia, you have to be specific here. Seeing an enlargement is not enough. You have to say it's a positive or a negative enlargement. All right. So there are three things you need to mention. You can unmute your mic, guys.
Sir, you can also say magnify enlargement.
Yes, you can. Yeah, you'll get the marks for that.
What makes it a positive or negative enlargement?
The both of them are on the same side.
So they're on the same side, it's positive.
That is correct.
So if it's on one of these three different sides, it's negative?
Correct.
Okay, thank you.
Yes. So to describe it, it's 3 marks. So there are 3 things we need to mention. Can anybody tell me what are the 3 things we need to mention?
Sir, the scale factor and center of enlargement.
That's 2. And the fact that you just mentioned that it's a positive enlargement. So here's how you'd write the answer, guys. Write it down for me, please. Try quadrilateral O. Correct, Geneva. Quadrilateral O maps onto quadrilateral M. Quadrilateral O maps onto quadrilateral M.
Sir, can you repeat, please?
Quadrilateral O maps onto quadrilateral M. Describes a positive enlargement. Describes a positive enlargement. If you want to be very specific and say magnified, describes a positive enlargement of scale factor. Put a dash. We're going to figure out the scale factor shortly. Of scale factor, leave a space or put a dash. Of scale factor dash about the center of enlargement. About the center of enlargement. About the center of enlargement. And open.
Sir,
Yes, go
after
ahead.
you mentioned about describing the positive enlargement, could you repeat that for me?
Quadrilateral O maps onto quadrilateral M. Describes a positive magnified enlargement
Right.
of scale factor dash. We're going to figure out the scale factor shortly. I'm going to tell you what it is. Of scale factor dash about the center of enlargement. About the center of enlargement. And we're going to figure that out shortly. Put an open and close bracket and leave it empty. Miss Hyman, somebody text it in the chat, so if you want to read it. All right. So let us figure out the scale factor. We don't have any vertical lines here. I went on a horizontal one, so we're gonna have to look carefully. Look at this one now. I'm gonna compare this side. I'm gonna compare this side with this side. All right. For the first yellow one, how many squares does it pass through?
1.
No, how many squares does it pass through? Look at it. Look at the big one right here. How many squares does it pass through?
2, sir.
2. And how many does this pass through?
1.
Good. So for the scale factor then, it's going to be equal to image divided by object, and the corresponding image is 2, and the object is, the image is 2, and the corresponding object is 1. So the scale factor is 2. So that means that the scale factor or the image is twice as large as the object. You could use any side. It doesn't matter. I just chose that side because it was quite obvious. I could have chosen this side as well. If I wanted to, I could have said, okay, then what is this side here? But then that one, they kind of know. In a really, it will pass through like pieces of the square. So I never want to use that one there, that's why. So yeah. So the scale factor is 2.
Sir, is this the one that you can draw the points to the points to
Yeah. This is what
something?
you're gonna use this one now and connect the two corresponding points and now to find the center of enlargement. You could use well, look here. There's another way you could do this now. Listen. You could use the
Because sir,
points.
I'm lost with the square thing that you were just saying.
Look at it here, some Miss Gentles. This here line right so. A 1 square. The line I pass through 1 square so. That pass through 1 next one here so. That a 2 square pass through. But it's corresponding with this here, which is going through 1 square.
Oh, that's what I was thinking at first, but then
Yeah, man. So 2 divided by 1 is 2, right?
you get it.
Yeah. Alright, you could use this one as well, because this one over here is passing through 2 squares here. And it's corresponding with this one, which is passing through 1 square. So that's 2. Well, no, sorry. Wrong comparison. This one is passing through 2, and this one is passing through 4. So 4 divided by 2 is still 2. We don't have to use the squares, I mean, you can just use the points. Look at this. So I could say, what is the coordinates of this? Right here, 1, 1. And, hold on there. Let us look at the points. Oh, this is going to be a problem, you know, because maybe it's not being... Hold on there, that one is tricky, you know. We're going to stick with the scale factor of 2. But the center of enlargement, now, hold on, can we draw one line now and see what happens? We're going to correspond. We're going to use these two here. This correspond with that. Draw a straight line through those. Sorry. All right, so that is the first line, correspond those. I'm going to need 2 more corresponding line now, 2 more corresponding point now. So those 2 correspond right there. And what corresponded what now? Them 2 here correspond. So I'm going to draw one line through them 2 here. Oh, so Johnny is not in the class. All right, so I'm going to draw one line corresponding these 2 here. These 2 correspond right here. It's kind of difficult, you know, guys, to draw it on the screen, you know, because I don't know. Yeah, so perfect, but it looked like it intersect right here. So the 2 lines are intersecting right there. 2 lines are intersecting there. So the center of enlargement right here says what?
1 and -1.
All right, correct. So the center of enlargement is 1, -1. 1, -1. But I'm still a little concerned about the center of the scale factor though. Because I'm looking at the points. Look at this now. Watch it for me now, guys. See if we can small up this like a bit. All right. Here to see here, so. Not true? Scale factor right here, man. You're right. Yeah, man, because if I compare these two distances here, right here, so, is 2 up 2. And then when I compare it to this side right here, this is what? 1, 1. This is 1, 1. So 2 over 2 is 1. Sorry, 2 over 2 is 1. And 1 over 1 is 1. So the scale factor is 2. Anyhow you look on it, it'll be the same thing. It's going to be the same thing, but I'm a little concerned. Maybe we can't use the points then. Let me see, this is 2, 3. And this is 3, 7. Scale factor 2, yeah, man. Sure, the scale factor 2. But I think I know what the problem is. I think why it's giving me a problem is because it's not being enlarged from the center. It's been enlarged from somewhere else, so the points are a little bit funny. That's why. So the scale factor is 2. Yeah, man, when you compare the image to the object, the scale factor is 2. All right, so we'll go do that one day. All right, next one says, describe fully the transformation that maps O now onto N. So talk to me now, guys. What do you think caused O to become N?
A rotation.
Rotation.
You think so? You sure?
Mm-hmm.
All right, it can be. I agree with you. It can be. It's a rotation. So what is the direction and what is the angle? Sorry, yeah. What's the direction? What's the angle?
Minus 180.
All right, Gallus, it's a rotation.
Counterclockwise.
Counterclockwise. That Richardson said that. Counterclockwise. Morgan said that.
Sir, flip.
Flip. It could be. It's possible. But you have to be specific. What do you call flip? Call the correct name.
Sir, I say it's anti-clockwise.
Anti-clockwise? It could be clockwise too. So why do you think it can go so?
So it will be 270 clockwise? Is that correct?
Could it be
270 would that be too much? 180 would be.
180 clockwise?
Yeah, because it moved from, basically make like a half a circle. Like that. 270 would go through 3. Remember, it's here, and it went here. So it went here, then it went here. So that's 290 degrees. That's 180. So I'm going to give you 2 answers, guys. Write these down. 2 answers. You can answer the question 2 ways. All right. Quad O maps onto quad N. Quad O maps onto quad N. Quad O maps onto quad N. Describes a rotation. Describes a rotation of 180 degrees. Of 180 degrees about the origin. About the origin. Quad O.
So you don't say you can't go. You have to mention clockwise or anti-clockwise.
In this case, you don't have to, because when you say 180, going 180 clock is same as going 180 anti-clock. So in this case, direction can be ignored. If you say 270 though, or 90, you have to be specific.
Okay, so
another question could be something what Kate was saying a while ago. She said flip, but that's not the correct terminology. So quad O, next answer, guys. Quad O maps onto quad N.
Sir, what did you say after you say 180?
That's it. After I say 180. What do you mean after I say 180?
About the origin.
Oh, sorry. Yeah. About the origin. Yeah, you don't have to say clockwise or anti-clockwise, because either direction where you go, at the same place you're going to land. All right, next option could have been quad O maps onto quad N, describes a reflection, which Kate Brown calls flip. Right, flip and then flip your marks. Quad O maps onto quad N, describes a reflection in the line
Sir, you lost me right after origin.
Sir,
That's it.
so the
Done.
one thing can have both?
Yeah.
The one image can have both
Yeah, of course.
reflection
Sometimes.
and rotation?
Yeah. Because a rotation is really a reflection in the line y equal negative x. You know? So look on a line here. Look at this line right here. A line here, so. Draw properly, but it's supposed to go through like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. A line here. The first one to draw properly. Let me see if we can draw it better. Hold on. So 1, 1, 2, 2, 3, 3, 4, 4. So the line here is the line called y equal negative x. So if you check it out, if you flip O over the line here, it lands on this, So you could say it's a reflection in the line y equal negative x. Yeah, man. That is correct. Both options. Two of them is right. Two of them is correct too. Just a minute, guys. Let me just let it in. Just a minute, please.
Sir, you said for II it would be a reflection that undergoes negative x?
No, it's a reflection across the line y equal negative x.
Your camera is on?
My camera is on?
Yeah.
Oh my god.
Remember, you don't want to let out your personal business.
Oh Lord have mercy. Can I tell you? Lord have mercy.
It's still on?
I don't know. Trying to get it up. Is it off now?
Yes, sir.
Okay.
Yes, sir.
All right. My apologies, guys. Good to go. All right. My apologies. I just had to let some persons onto the other platform. All right. So we'll do that now. Okay. I think everybody's okay. Moving on down here. On the diagram on page 24. On the diagram on page 24, we're to draw the image of quad O. On the diagram on page 24, we have to draw the image of quadrilateral O after it undergoes the following transformation. So this is a translation, right? Once a translation, ladies and gentlemen, all the points will be moved by -5, 2. So go up here. Let me clean up this diagram here. So all the points that is on quad O, all the points that is on quad O will be moved -5 up 2. So watch me now, this point. 1, 2, 3, 4, 5, up 2. It's going to be right at that position right there. All right, the next point is going to be 1, 2, 3, 4, 5, up 2. It's going to be right here. Next point, 1, 2, 3, 4, 5, up 2. Right here. And then 1, 2, 3, 4, 5, up 2. Right there. Connect them. All right, everybody get that? Everybody got that?
Yes, sir.
Yes,
Go
sir.
again, sir. Go again.
When it's a translation, all the points on the object that they are asking you to translate will be moved in the direction of this number. So -5, so you must move 5 to your left, and 2 goes up. So all the points that I did earlier, I jumped them 5 places. So I'm looking at quadrilateral O here. And what I did is that I jumped all the points. Look, 1, 2, 3, 4, 5, up 2, lands right there. 1, 2, 3, 4, 5, up 2, land right there. 1, 2, 3, 4, 5, up 2, land right there. 1, 2, 3, 4, 5, up 2, land right there. That lands me in that position.
All right, thank you, sir.
I have a question.
Sure.
Why did we go left and not down?
First number tells us the x value.
Oh,
Second number
negative.
tells us the y value.
Okay.
All right, so everybody's good at that. That shouldn't be too tough. All right, it says reflection in the line y equal -1. I think we spoke about this yesterday. So this is the third time now we've seen something that we talked about yesterday coming back. I think yesterday we did what was it? Anybody can tell what we did yesterday? I think we did something like this here. And then I told you guys that they may say to you, if them say y equals something, you draw the line. Anybody can vouch for me? Is this what we did yesterday? Nobody from yesterday's face-to-face class can say, sir, we done do something like this here? Nobody? All right. No worries. Because nobody now vouch for me. Anyways, y equal -1. So go draw one line right here, so. So that's the line y equal -1. So O will go across this red line. and it's going to be the same distance on the other side. So the question is, how far is this point from that red line? How far above the red line is that point? Are you guys hearing me?
Yes, sir.
Yes, talk to me now, Jayan. How far is that point above the red line?
One, positive one, positive one.
No, man, like how much distance? That's all I want to know.
Sir, 2 squares or 2 boxes?
Yeah, 2 units. Yes, Anthony, I see you, darling. I see you.
Sir, my head wasn't clicking at the moment, and then made that think about it more complicated more than
No,
that.
man, it's just how far above the line is how far above is the line? How far above
Okay,
the red
sir.
line is the point? Yeah, 2. So it should be 2 below, right? If it's a reflection, 2 below. How far is this one above the line? This one right here. How far is it above the line? Correct. 1. So it's 1 below. All right. How far is this one above the line? How far above?
3.5.
What you say? You sure? Look good. Count it. Count the lines them that takes you to the red line from this position here. How much lines take you exactly to the red line? Correct, Antonia. 4. 1, 2, 3, 4. So it should be 4 below. 1, 2, 3, 4. Right on yourself. And how far above is this line right here as well?
2.
This one, 2. All right, 2 above. So 2 below. So 1, 2 right here. So connect them now. Boom, that's it. Everybody go do that?
So can I see the
Yes,
question
sir.
again, please?
Yeah. Here it is. So the first time we did it with the blue, we were supposed to move it 5 to the left and 2 up. Move the entire shape 5 to the left and 2 up. And the second time we did it with the red, we were supposed to put it on the other side of the line y equal -1.
Okay, thanks, sir.
Yeah. All right. And that's it. Okay. Come on, I want to say with the trick there. I was wondering what's going on, A boy, B, and I know what a boy is, by the way. Just for knowledge purposes, y'all know what a boy is?
No,
No,
sir.
sir.
No, sir.
That floating thing out by the sea.
Is
Correct.
a boat thing?
It's the thing where they're not the sea. It's something we tell us don't cross the line here. I go drown.
Sir, the rope-looking thing?
No, not the rope, but the thing with it on the rope.
Oh, the circus thing.
Right.
Okay.
But it's far out on the sea. You know that thing that we tell us that in this area is where large amount of fishes are. So it's like a buoy, it's like a marker in the sea. All right. So just in case we don't want it to throw you off. Okay. A buoy B and a lighthouse L are 95 kilometers apart. But here what problem now? The bearing of B from L is 230. Using a scale of 1 centimeter to represent 10 kilometers and the space provided below, complete the diagram to show the buoy relative to the lighthouse. Indicate the given bearing on your diagram. And the first time this CXC sent on one question that you have to draw the diagram in almost 12 years. CXC start to talk with the ball and now. Because I saw me did learn bearings. When I was learning bearings, I had to draw the diagram. For the past 15 years, if I'm following these papers correctly. They have not allowed you guys to draw the diagram. Them draw the diagram and make you put on the bearing on the diagram. But luckily, all of my students when me teach them how to do this. Because I told you that whenever you're going to draw a bearing, the first thing you need to do is to establish a what? A north line. And as you can see right here, the north line is already established. Now, what do we need to construct the bearing? Start with G.
Share the guideline.
That is correct. We need the guidelines. So we are on a bearing of 230. No, so we need this guideline here. And we know what the purpose of the guidelines and be. The guidelines are going to help us later on, if possible, to cut up the angles them into small portions. So it's easier to find. So this guideline right here. What is the degree of that guideline?
90.
90.
Good. What is the degree of this guideline down here?
180.
So we know the boy is not in any of those directions. What is the guideline of this boy of this? What's the degree of this guideline over here?
270. 270.
We can confirm that the boy should be somewhere in this direction. Now, 230 is almost near to 225. Because remember, 225 is exactly between. So I can just pretty much do like this. It doesn't have to be accurate, but we just know say somewhere in that direction there, the boy is located. And them say it is what, 95 kilometers apart. So I can put my 95 right here. 95 kilometers apart. And now where are you going to put the bearing? The bearing is measured from where in what direction? The bearing is measured from where?
Clockwise.
From where?
From the point. Line.
From north. So all of that angle there is 230 that I've circled in blue. But what does our guideline do for us now? Our guideline allows us to find that little piece of angle in there, so. Because we don't know, say you saw what already? 90. Here saw what? 90
again.
Not true? So you saw 50. You know how we get 50, right?
Yes, sir.
And that's the purpose of the guidelines. All right, and then we're going to put the boy down here.
230.
So Johnny, mic is unmuted, Dove. So Johnny, mic is unmuted. All right, good, thank you. All right.
Sir.
Yes. Go ahead.
Sir, how you get the 50?
The full
It's
angle
40.
is 230. It's 40? Check good, man. You sure it's not 50? Hey, Alicia, yeah. So 180 from 230 to 50? Hey, so now say 40. Everybody good with the 50?
Yes, sir.
All right, cool. All right, good. All right, let us see what they say now. No, remember this, because this might play a role, Feel like this is going to come into play, because they must say something here. So use a scale of 1 centimeter to represent 10 kilometers. And the space provided. Complete the diagram to show the boy, which we have done. Relative to the lighthouse, which we have done. Indicate the given bearing on your diagram. We have done that. So indicate the 230. So we go, don't forget to put on the 230, people. Because the 90 and the 90 and the 50, how we break it up. So this angle here is 230 degrees. All right, cool. So we have that. And the boy is down here. B. All right, that's it. 3 marks. Lovely. Moving on. A lie. People a lie. I couldn't that CSEC come good, After how me beat at this all the people them send come. People, Zaina, please tell me say a lie, Matel.
Let him until.
I have
I
a lie.
can't believe this.
That 2026, this is 2 months ago, or 3 months ago. A lie.
Sir, I think you did not go long.
Sir, paper done.
Thank God.
No, not the paper done. Question 10 done, the very thing we carry and some of the other students don't like. The very thing we wanna run from.
Sir, the very thing what me like.
Sir, but me not get started. You're supposed to glad it.
No circle theorem na there. What is going on?
Sir, I hope that's how they do the one we're doing on Tuesday.
Hey, people raise my hand. Raise.
Sir, I wonder if they're planning to send a lot on Tuesday.
I wonder them a plan for tests. Oh no. I wonder. Wanna think? Wanna feel? No, I need the circle theorem.
No, sir, me like this. No, me like this.
You like this? If I hear Kerry voice, I must know. Oh God. Hey, if they ever try this, my students them would have flagged CXC.
Sir, there goes some of my score.
Maybe because of the storm when it come, it not come hard. Well, lots of assumption. Okay, people, please prepare. Don't prepare. Yes.
Some feel like them want to go like them do that for the person them like who still them for like this time and everything when it happen.
If
Them
you
give
so,
them that, but them feel like what gonna happen for Tuesday I go much more like them I go test your mind to see how far you can go.
I don't know. Lexi,
Hi, sir.
this was the paper that I stopped you from doing,
You
hit me
stopped
now?
my blessing.
Oh
my
God. I'm sorry. Oh my God. All right, go me kick it out now like a ball. This is an actual exam paper, joke this come. The functions f and g are defined as follows. Oh yeah, please. I did tell you still, so me no want to see this here and get thrown off, All right, at the same f of x and g of x here, just to make sure someone know that, so don't get thrown off. All right, so the formulas for f of x is f map onto x is x squared plus 3, and this here. Calculate the value of g of -1. Easy one mark. Talk to me, people. Easiest one mark in our life. Talk to me, tell me if you write down.
Sir, 0.
No, I know the answer, more the steps.
On the step.
2 times -1 plus 2, comma, -1, whatever the sign will be r.
Answer what?
0.
You like what Alisa say, yeah?
Sorry, that x something there.
Which x?
With the side of it.
No, man. This here, sir, this is just telling you that the answer is a member of a real number.
Oh.
Yeah. And this up here is just telling you that the answer for x up here, sir, has to be either 0 or greater than 0. That's all it's telling you. What a lucky thing this come up. Just ignore that something, man. This is just it's just telling you where the answer, the range is, or the domain of the answer. Next one. F minus 1x, and everybody know what that is?
Yes, sir.
Inverse?
Yes, sir.
Let y equal f of x, which is going to be what? X squared plus 3. Interchange x with y. X equals y cubed, y squared plus 3. I need to get y by itself. Talk to me. Carry over the 3.
Sir, -3.
Correct. Equals y squared. How do I get rid of the square off of the y? Correct, Antonia. Square root x minus 3. I will end up with y. But hold on, we need to draw one conclusion. What's the conclusion? We'll find y, so we'll find the inverse. So therefore, we have to draw one conclusion. F inverse x equals the square root of x plus 3.
Sir, but so must always put the negative and the positive.
No, x minus 3, sir.
Sorry, sorry. We even say Alicia?
So you said to always put the negative and the positive sign of the square roots.
Oh no, man. In this case, now you're not finding the square root of a number, you know. You find the square root of an expression, so the plus or minus can be ignored. So if I say find the square root of 100, you have to put plus or minus 10. But if you find the square root of an expression, you can just ignore the plus or minus. And if you put it there, it won't hurt you. Alright, so that's it for that one. Easy 2 marks. Derive a simplified expression for g of x. How do we deal with that part now?
Put the f function in the g function.
So we drill that, my g. So we're going to put the f function into the g. Let me just clean this up. So we're going to put what into what now? You say f into g. So we're going to take this f function right here and put it right as so. So we're going to put all of this thing that I circled here and put it right there. So I could mod CSEC Mathematics and this going to give me a pit in them. After 1 year, no, so I could mod them mod. Could mod them mod. So this is 2 times x squared plus 3 plus 2. Everybody go do that?
Yes, sir.
2 x squared. You have to distribute. So distribute that. 2x squared
Plus 6
plus
plus
6 plus
2
2. Answer is what? 2x squared.
plus 8.
That's it. If you want factorize and play both in here, you can do that. 2 open bracket x squared plus 4. If you want show off and hype on them, no problem. If you want pop some style on them. 5 marks. Awesome. And I think this is send them. They couldn't mod. They could not be mod. It says given that fg of x. It says given that fgx is this. So they're saying that when you put g into f, this is what comes out. You have to solve this equation. So solve the following equation. Fgx equals. All right. What think about that one now?
So this looks like a whole bunch of madness.
All right, we'll see. Can we break it down now? We'll break it down, you know. So they must say, so the first time now we see one question we actually have to think about. So they're saying that this thing right here. So they're saying that this thing right here is equal to this. Cool. I understand that. So we have to solve the equation, right? If this thing here is equal to 2 times this thing here. All right, so go set it up then now. Let me clean up this. So we're trying to solve this thing right here. So fgx is equal to 2g fx plus 15. But we were just told, you know, we were just told that this thing right here, so is this. So we can put this thing down here. 4x squared plus 8x plus 7 equals. And them say it will equal to 2 times this thing. But this thing, right as so, how we did work out in the previous question. We didn't work out this in the previous question. See it up here, so. What was the answer that we got for that? You guys wrote it down or no? Anybody did write it down? We
Yes,
erased
sir.
it a while ago. What was it that we
Sir,
got?
2x
What's our
squared
answer?
plus 8.
2x squared plus 8. And then we can plus back the 15. So we'll solve this equation. All right, before we move on, everybody good with that?
Yes, sir.
So I just the hardest part of this was to interpret what it was saying.
Sir,
Yes, go ahead.
could you go over it one more time?
Go ahead. I'm listening.
No, I'm asking
I'm
if you
not
can
hearing you,
go
Ashley.
over it. Could you go over it one more time?
Okay, all right. So this is what they ask us to solve, you know. So this is what they've asked us to solve. They ask us to solve this thing right here. But if you notice that right here, so we were told that that thing is this. So see it so them tell us that thing right here that we're looking for is other this thing right here. So I'm gonna grab that and I'm gonna put it right down here, so. And then now them say it must be equal to, because them say it equal to this thing, which is 2 times that something here. So it is 2 open bracket, that's something there. But this something, this gfx is what we had in the previous question up here, which if you check out and you were writing down the solution that we had, we worked it out and we got 2x squared plus 8. And then someone add back 15 to it. Huh?
So the solution that you have, the 2x squared plus 8, wasn't in bracket. So that solution would be wrong. The solution that you had in bracket was you had the 2 outside the bracket, open bracket, x squared plus 4.
That after me factorize, I show off me when I show off that time, man.
Sorry, you're supposed to still have the 2 plus the 2x squared in bracket plus 8?
Yeah, man.
Okay.
Yeah, man, the 2 open bracket x squared plus 4, I was just saying that if you want to show off on them.
Okay.
All right, cool. Let's break this thing down now. So we're gonna have 4x squared.
Sir, question.
Yeah, man, go ahead.
Sir, are we solving for x then?
Yeah, man, it's a quadratic equation, but we have to break it down.
Okay, then.
We have to simplify it now. So 2 times 2x squared is gonna give us what? 4x squared. And 2 times 8 is 16 plus 15. All right, can we put everything and make everything equal to 0 now? Make everything nice now. Everything from one side. 4x squared. Carry this over here. Hold on, where's my equal sign? It disappeared. It's supposed to be there. I think my equal sign was missing. Hold on. I left off my equal sign. So this is equal to 4x squared plus 16 plus 15. So carry this over here now. 4x squared minus 4x squared. And we're going to have plus 8x. That's the only thing there, so then we're going to have plus 7. When we add them 2 here together, we get 31. When time we carry it over, we get minus 31. Look carefully, guys. When I add these 2 things together, we get what? 31. And when time we carry it over here, so we get minus 31. So 4x squared and everything equals 0. 4x squared minus 4x squared, delete. So we end up with 8x plus 4 equals 0. Oh, it boils down to something simple. Okay, that's nice. Carry over that. 8x equals negative 4. X equals negative 4 over 8. X equals negative a half. Okay, works out nice. Thought it was going to be more complicated than that.
Sir, how did you get the 31? Because of mine.
Oh, hold on. Huh? Hold on. The 31 was because I added the 16 and the 15. That's all.
Sir, I have all of that, but I minus 7 from 31 instead.
Oh, yeah. Let me get 30. Let me get 4 from. I'm supposed to get. So, where you get when I subtract that? I get 24, right? Negative 24?
Yes, sir. Negative
Yes,
24.
sir.
So, where me get 4 from?
Sir, I don't know. Maybe mine is wrong. I'm not sure.
No, man. You're on right, man. But where me get 4 from? What am I thinking about? Or is it that in my mind I said 24 and then write down the 4? No, my ear is not wrong, man. You're right, man. I see it as soon as you call me name, and you're about to correct me, I realized I did something wrong. But when I said, where me get the 4 from? In my mind, I don't know where I get the 4 from. Maybe I'm tired. Come in. So 7 minus 31 is negative 24. As a care about that, we're going to get positive 24 here. That's what Antonia has the 3 in the bracket in the comments.
Sir, question.
You talk to me.
It should have been positive 31.
No, but we must carry it over.
Oh, yeah. All right, then.
X equals minus 3. All right. I know a bad question. Oh, Kerry get minus 3 too. Okay. All right, nice. All right, that wasn't a tough question. Quite some thinking, but I'm not crazy. I don't think it was that bad. Was it that bad, guys? Was it that bad? Like, was it bad to the point where you said, no, sir? This is something.
Sir.
It worked out nice. All right, that's a question 8. Pattern and sequence. Oh, remember, guys, as soon as I see this, remember tomorrow, 6 o'clock, 8 o'clock, we're going to run through a couple of these here.
I think you skipped a question.
I did. Please correct me. I don't mind. Oh, the part you don't use so. On the grid provided in the answer booklet, which we don't have, plot the graph of the functions f and g for x is greater than 0. So these are 2 straight lines, people. These are 2 straight lines. Oh, may I erase this? Can I erase this now and drop my sketch? How you get minus 3, sir? 24, negative 24 divided by 8, Kyle. Kyle, you get that?
Yes, sir, but wouldn't the negative 24 go for, sir? Positive?
No, man, we don't carry it over, my G. Remember say, I divide by 8, So I need to carry over the 24. When it's a carry over, you mean like carry it over here, so? Oh, me get what you say, Kyle. Me get what you say. Yeah, me see what you say. Oh,
yes, sir.
So boom, it's a positive when you carry it over. Positive, so it's a positive 3. So Kerry, you're minus 3, and Antonia is saying that it's 3. All right, good job, Kyle. Good job. Good identification. Small things can make you lose marks. All right. No worries. All right, so I'm going to erase this now. All right, so it says, on the grid provided in the answer booklet, plot the graph of the functions f and g for x is greater than 0. So we're going to plot the line here. We're going to plot x squared plus 3 All right, so let me draw a graph here. So here's a line. So that's my Cartesian plane, right? So let's look at the graph of this thing here. Whenever a graph has an x squared, it's a curve. Are you familiar with this thing that we used to do in class? Are you guys familiar?
Yes, sir.
Yes, so enter you see one graph, we have an x squared, it's a curve. So watch now. You see the graph of x squared, it's this graph. Draw it better, please. So the graph of x squared is that. Now, because you add 3, the graph is going to climb up 3 spots. So the graph, so watch me now, look at the demonstration now. The black curve that there, that is the graph of x squared. It's a given graph, it's a something you know. It basically goes right through the origin, swings like it's like a bowl, right? That's the graph. And because it's plus 3, you're gonna climb up 3. So the actual graph is going to be this. So the actual graph is going to be this. All right, and we can just erase the black one because it climbed up. All right, so this is the graph of x squared. This is the graph of x squared. And then because it climbed up 3, because it goes up by 3. All right, that's all. All right, next one now is the graph of 2x plus 2. There's no square on it. That means it is a straight line. And if it's a straight line, the line must cross the x-axis and it must cross the y-axis. All right, so can somebody remind me now, when a line crosses the x-axis, what happens to y?
Equals 0.
Or we just use an I word?
Ignore.
Ignore. So if we want to find the x-intercept, then we just ignore the y. Or we make y be 0. So we're going to end up with 0 is equal to 2x plus 2. Carry over this. Negative 2 will be equal to 2x. So if you divide both sides by 2, we're going to get negative 1 is equal to x. So therefore, this line here is cutting the x-axis at negative 1. So negative 1 should be right here. That's negative 1. All right, now similarly, if we want to find the y-intercept now, so if we have y is equal to 2x plus 2, and we want to find out where it cuts the y-axis now, we just replace the x with a 0. So that's y is equal to 2 times 0 plus 2. So y is equal to 2. So that means it's crossing the y-axis right here at 2. So by using a ruler, you can draw a straight line connecting a line from straight through -1 through to 2 like that. Shoot off like that. Miss it. Hold on. Try it better. No, sight bad. I said in a perfect, but you get me. I'm trying to say. To go try to pass through here and here.
How did you get the y for the 2 for the y again?
2 for the y. I made x be 0.
Oh.
I made x be 0. So until you want to find the y, make x 0. When you want to find the x, make y be 0. So that would be your graph that you're looking at. So that's it. So we just have questions 7. Question 7, question 6, and question 5. And question 4. Okay, we can run through these in an hour or an hour and a half. Let's see. All right. The diagram below shows everybody okay? Everybody good?
Yes, sir.
Yes, sir.
Remember, this is what's going to happen on the paper, people. You're going to, when you see something for the first time, you're going to have to figure it out. If I had worked this paper like before I came here, a easy flow. But when I do it like that, it'll seem as if I can't make mistake. When I make my mistakes, I can correct myself. And that's what is going to happen to you too, right? A lot of the papers that you'll watch online, the teachers, they work out the question before. And when them come, them sound flawless. But in reality, the flawlessness only exists because you already know the answer be. This is organic teaching. So you see the mistake, you see the problem, you try to figure it out. This is what is going to happen to you guys when you go on the exam, right? You're going to see the problem, you're going to figure out a solution. You're not going to feel right, you're not going to sound right, you're going to correct yourself, fix this, fix that. This is how it is, okay? That's just my opinion still. All right, let's go. The diagram below shows the first 4 figures in a sequence of figures made up of squares of unit length. All right, now we can see the pattern. All right, let's figure out a pattern. It's a 3, it's a 5, it's a 7, it's a 9, right? So 3, 5, 7, 9. It's pretty much something I'll go up by 2. But most importantly, when I realize what I realize here, what I realize in terms of me drawing the next diagram, if I have to draw the next diagram, what I realize is that I have a block here. I'm attached on a block on it. I end up with 2 set of block here. I'm attached on an extra block. 3 set of block here, attached on an extra block. 4 set of block here, attached on an extra block. So you see what I'm going? There's so many ways to look at the pattern. So it says complete the diagram to show figure 5. So complete it. So for figure 5 now, we're going to have 5 set of double blocks. So I'm going to have 1 block here. So that's 1 set, 2 set, 3 set, 4 set, 5 set of double blocks. And then we just cut out one extra block on it right so. Everybody comfortable with that? Following the pattern, everybody good with that? Everybody can wrap their mind around that?
Yes, sir.
Yeah, man, that shouldn't be too hard based on how you follow the pattern. All right, so we draw that, we get with 2 marks. That's nice. Nice 2 marks. Go down to the table here. The number of squares. The number of squares Q. So they're talking about the numbers in here. And the number of sticks S here. Talking about those numbers there. And the perimeter of the figure here. The values of Q, S, and P for the first 4 figures are shown in the table. Study the pattern of numbers in each row of the table and answer the questions that follow. All right. Now, I was doing this on a TikTok live the other day with about 60 or 50 people, something like that. I don't know where them come from, but it was fun. And I showed them a shortcut that works most of the time. Follow the pattern going down. What's the pattern going down?
Sir, 2 is being added.
All right, so Alicia, so usually what I tell my students is that I try not to give them the formula first. I try to get them to understand the pattern and how the formula is derived, right? I realize a lot of persons, I think, I don't know, there's somebody teaching it this way where them figure out the pattern and then send the students and go up. I don't do it that way. But if it works for you, no problem. So the pattern coming down is going up by 2. So that means chances are I'm multiplying this by 2 and then I'm doing something to the result to get back 3. What do you think?
Add 1.
I'm adding 1. All right, so that means say I'm going to multiply this by 2 and add 1. Talk to me. What me get?
11.
Good job. All right, what's the pattern coming down?
5.
5 is being added.
5 would be multiplied. Should I say added, Alicia? Check.
Yes, sir. Added.
Oh, yeah. That you mean. Yeah. You're right. So you're adding 5 every time, right? So chance. Right. So chances are you're multiplying over here, so by 5. So 5 times 1 is 5. So what must you do to get back 10?
Add 5.
Add 5. So 5 2 is 10. Add 5. 5 3 is 15. Add 5. 5 4 is 20. Add 5. So you have to figure out a pattern that works for you. Not works for you, that works with the table. So we're going to multiply this number by 5, which is going to give us what? 25, and add 5, we're going to get what? 30. All right? But if you want to work it this way, coming down, add 5. My problem is that when you're adding 5, what if this wasn't 5? What if this was 25? Or what if 17 or 19 or 13? You can't add 5, It has to be immediately after for you to add 5. All right, cool. Look at the perimeter now. Let's observe the perimeter. The perimeter is what? Going up by what?
2.
Perimeter is going up by 2. So go try something now. 2 times 1.
2.
And what you have to do to get back 8?
Add 6.
Let us check and see for the same thing. 2 times 2.
4.
What you have to do to get back 10?
Add 6.
2 times 3. 6. Add 6, get 12. 2 times 4, 8. Add 6, get 14. Catch a pattern? Everybody go check?
Yes, sir.
So that's the trick, Alicia. Figure out the pattern that's going down. Whatever pattern is going down, multiply it by the number over here, and figure out what you have to do to get back that number. That's usually the pattern. And I found like 6 past paper questions that had the very same pattern.
So I've never done it that way. I've always just found the formula for n and then put in the values.
I seem as if that's what a lot of persons on the internet
That's
are
what
doing.
my teacher taught me.
Yeah, man. I realized that a lot of persons on TikTok the night, a lot of persons were telling me to do it that way. No, sir. I don't know that way there. I mean, if it works, it works. If it works, it works. All right, so now, we know how we got here. So let's do the opposite. We know we had to multiply over here by what? 2 and then add back what? 1. So do the opposite of adding 1. Subtract 1, right? 46 divided by 2. What you get?
23.
Correct.
23.
Lovely. Very good. And we know what we had to do here. We had to what? Multiply by 5 and add 5. So subtract 5 and then divide by 5. Do the opposite of what you did to get there. So subtract 5, 115. Oh no, we don't need that. We don't need it. We already have it. Right. What do we have to do to get here now? We have to multiply over here by what? 2 and add 6, that's true. So multiply this by 2.
52.
And add 6. How much you got?
52.
All right, 52. Good. So now, Alicia, I'm ready for you now. The formula here is what? 2n plus 1, 5n plus 5, and 2n plus 6. All right, all my people, on the good? Avian? Everybody okay from my side? My side, on the good?
Sir, the 6. So 2n plus 6. I get the 6.
Remember, say you just tell me how I can multiplied by 2 and add 6, sir.
Oh, yeah.
Latisha, when me lose you? When me lose you, Latisha? When me lose you?
Sir, because over perimeter P looks like it's going up by 2.
Yeah. But then when you multiply over here by 2, what do you have to do to get back the 8? And if it's going up by 2, then it's gentle. Remember, say 5 with the day, so we skip past the whole of the numbers in Marriage 23. You couldn't want to write 18 yeah, so.
So
And we
what you
skip
multiplied 2 by?
by every number over here. And
Okay.
then figure out what I have
Okay,
to
because
get.
I was wondering what you multiplied by.
Yeah, I multiply. So remember, you know, the figure is what we multiply. So the pattern going down, it's affecting the figure. And then we have to do something to the result to get back the answer that we are looking for.
Okay.
Yeah. So we couldn't go up by 2 here and get 18 because we were at 5. The next number is not 6. The next number is 23. All right, Latisha, good now or no?
Somewhat.
All right, I will just watch back the recording because we have much to do. All right, so Mala says that she can make one of the figures with exactly 502 squares. Explain why she's incorrect. They gave us this question last year, 2025. So she can make exactly what? She can make one of the figures with exactly 502 squares. Explain why she's incorrect. All right, so let us see now. If we take 2n plus 1 and equate it to, she said Mala can make one of these figures with exactly 502 squares. Oh, so we're going to use the formula for here, so square formula we're going to use. Because it's a stick formula, you know? It's the perimeter formula over here. So we're going to take the 2n plus 1 and equate it to 502. Over here, 2n is equal to 502 minus 1. So 2n is equal to 501. So if you divide both sides by 2, we're going to get a decimal. And you cannot have a decimal amount of squares. So we're going to get 250.5. Where you get 250.5 squares? That don't make no sense. So there cannot be any decimal equivalent squares. Notice that all the numbers here are whole numbers. We're getting a decimal. So your reasoning would have been in a statement form that Mala cannot make an exact figure with that amount of squares because the number of squares, the number of figure would have been a decimal figure. You wouldn't have 250.5 figure. All right, so you'd write a statement that kind of explains what this is right here. And that's it. On a field, out of the 10, how much you can get?
10.
All right.
10.
10, sir.
10. Everybody can get 10. So remember, people, the shortcut is figure out the pattern going down. Oh, at least I say I can figure out the formula to win, but as I said, she's taught by somebody different. So a lot of person will take it to find the formula first and then insert the values into the formula. But I kind of prefer to figure out the pattern going down. Then I would just use the pattern going down to multiply the figure and figure out what I have to do to get back the answer. That makes my understanding clear. So Ellie said 9, 10. No, look all right. No, look all right. All right. So earlier I want to say question. Earlier I want to say question. All right, so look at this now. Earlier I want to say question what? 1, 2, and 3. Some brothers say 20, 22, 27, 26. That are questions 1, 2, and 3. This question is a 10 that are what? 33, 32, 35, 36. And then now we know so around at the back here, so functions now might get some marks around there, something. Down here, so. Transformation I might get something too, something here, like a trig, sine rule, cosine rule. All right. Look like we can get the 60 points. When I believe we can get the 60. Y'all believe we can get the 60 points? All right, we are going good. Number 6, measurement. A map is drawn to a scale. Normally, they give you something that's drawn, not drawn to scale, but a map is drawn to a scale of 1 to 20,000. On a map, 1 centimeter represents n kilometer. We don't know what that be. Them say determine the value of n. So What this is saying is that 1 centimeter on the map actually represents 20,000 centimeter on the ground, and that it mean. That's what this ratio thing mean. 1 centimeter on the map represents 20,000 centimeter on the ground. So we want to convert the centimeter to kilometer. So knock him down, man. Don't commit murder. We're at centimeter, and we need to get to a larger unit. If we get into a larger unit, we're dividing. But dividing by what? 10, 100, 1,000, 10,000, 100,000. So therefore, it's going to be 20,000 divided by 100,000. All right, so go ahead and divide that for me, please. What is 100? What is 20,000 divided by 100,000?
0.2.
That's it. So n is 0.2. So n is equal to 0.2 kilometer. But go do that.
Sir, can you go back over how you converted it?
How do I convert it? I use this mnemonic. Knock him down, man, don't commit murder. So based on the scale that they gave us here, they said that the scale is 1 to 20,000, and that means 1 centimeter on an actual map, like a physical map we have in your hand, actually represents 20,000 centimeter on the literal ground that is represented by the map. But because we are at centimeter, and we are told that 1 centimeter represents n kilometer, they're basically asking to convert from centimeter to kilometer. So we're at centimeter right here, and if you jump, go all the way back, all the way up here. And if you're converting from a small to a big, you're going to divide. But depending on how you divide by, based on how much decimal places you're going backwards. So here is 10, 100, 1,000, 10,000, 100,000. I'll divide 20,000 by 100,000, I'll get 0.2. Good to go? Good to go, people?
Yes, sir.
Distance on the map in centimeter, which corresponds with an actual distance of 4.8 kilometer. So remember now, 1 centimeter on the map, represents what? We just get it a while ago, 0.2 kilometer.
0.2 km.
Good. Not true. So we want to find out. So 1 centimeter on the map, represents 0.2 kilometers on the ground. Now we're on the ground, which is 4.8, not true? And a 1 marks, so it's not hard. So this is just basically saying what? 4.8 divided by 0.2. How much is that?
24.
24 centimeter. That's it. That's it. But them say the distance on the map in centimeter. Oh, so they want it on the map in centimeter. I must multiply this by 20,000. Let's think. 1 centimeter. So it says on the map, 1 centimeter is this. A map is drawn to scale, right? So one of two things. I'll play it safe. So I know that after the conversion is 24 centimeter on the map. Yeah, that's it, guys. 24 centimeters. Because they said on the map. They didn't say on the ground. So on the map. All right, next one says actual area in square kilometers of a lake which has an area of 12 squared centimeters. Mm-hmm. So in order for us to do this then, it says we want the actual area in squared kilometers. So first, I would take the square root of the 12. If we go backwards. So what's the square root of 12?
3.46.
So this would be 3.46 centimeter. That is on the what? Actual map, not true? And then sending one the area in kilometers. So 3.4 centimeter. Hold on the people. Actual area in squared kilo. Yeah, go ahead. Suggestion? Alright, so Antonia says you
Sir,
could
so
multiply.
what would we do with the 12 then?
No, that's why I took the square root of 12. I'm thinking that I should take the square root of 12. The actual area in squared kilometers. I'm never usually good at these questions, you know. The actual area in square kilometers.
Hold on, let me...
Yes, actual area in squared kilometers of the lake, which has an area of 12 square centimeters on the map.
You would multiply the 3.46 by
20,000?
Yeah, by the I think the K.
The K?
Yeah.
Which K?
No, where I said knock him down, the value will be.
No, my last say so. Talk to me. What you say?
Alright, so same like how you do the 20,000 divided by 100,000. You would multiply the 3.46 by 100,000.
You think so? Me, I wonder. Go try it now. Go try it, you know. And see what happens.
Yeah, I did that already.
How you get? You get something crazy?
Yeah.
That not sound like you right. For you to do that. It
It's
doesn't sound like you right.
it's a long number.
No, I not think of that. I not think of that.
It's 346,410.
Alright, so hold on. Go test it then. What if we multiply this by 20,000? How much you get? Go try this. So 3.14 times 20,000. What do we get? Alright, so Antonia says you could multiply the 100,000 then divide it by 20,000. If you're not sure, 3.46. Square 0.2. Then multiply by 12, you get 0.48 kilometers. Well, I'm missing what Antonia say. Somebody's in the chat making a suggestion. Antonia is saying that we should take the 0.2, which is what we got up here. And she's saying that we should square it. We should multiply it by 12. All right. And you get what? 0. What? 0.48. So you take the 0.2, which is what we got up here, and we multiply it by 12, which is what they're asking us down here. All right. You get 0.48, and then you say...
Sir, but 0.2 times 12 is not 0.48.
It's not?
I got 2.4.
Square 0.2 times it by 12, you get 0.48 squared. Squared. At least I get 69,200. 12 times 0.04. I'm reading the comments, guys. Sir, square root the 12, you get 3.46. I have 3. Okay, yeah. That was a mistake, Ajanai. No, sir. Square 0.2 first. Oh, all right. So Alisa, she's saying that we should square the 0.2 first. Miss Wagon. So she's saying take the 0.2 that we have up here initially, and we're gonna square it. And we're gonna get what? We're gonna square that, what we get? 0.04. And then she's saying that after we do that, we're going to multiply it by 12. And that's how she get the 0.48. Alright, it sounds like it makes sense. So the actual area in square kilometers of the lake, well, it sounds like it makes sense, but the working out kind of does look kind of shabby. I don't know. What do you guys think? Yes, I got 0.48 square kilometers. All right, you know what? Give me a second there. I'm usually not very good at these questions. You know, it's the area question here on the map. I usually just try to figure out a way around it, but let me figure something out. Anything at all that I can't do, a little research will help. All right, so hold on. Give me a second, guys. Let me clean this up. I'm going to tell you if you're right, Anthony. Just give me a second. Just give me a second, please. All right, so get part A. So you get the 0.2, right? All right, and yes, Anthony, you're correct. You're correct. She's correct, guys. She's correct. So the answer to this is to take the 0.2, square it, then multiply it by 12, and that's the answer. Yeah. Well, Gauss Mass said that it is right, so yeah, just work with that then. All right, go move on. The diagram below shows a running belt E, F, G, H, I, J. So E, F, G, H, I, J, E, F, G, H, I, J. Also, it keep going around in a circle. Okay, that revolves around a running board on a treadmill. In the diagram, EJI and HGF are semicircles with diameter of 0.7. All right, cool. And EFHI is a rectangle. All right, so these are basically semicircles. And this is a rectangle. All right, cool. Let's see now. What are they saying that we should do? Use pi as 22/7, calculate the length of the belt. So we want the distance coming around like that. All right, so guys, quick question. When you put two semicircles together, what you get? If I were to take the two green thing that I highlighted, what would we get? You get a full circle? Not true?
Yes, sir.
And opposite sides of a rectangle is the same, is equal, right? So this is 2.1 as well, not true? So if I put these two here, this part and this part together, I get a circle. So the length of the belt here is going to be the area of a circle. So the length of the belt is going to be area of a circle plus 2.1 times 2. Everybody good with that? Everybody good with that interpretation based on the analysis? So if I put the two green things together and join them on, right? Then the curved part attached onto the other curved part will give you a full circle. Or we need that distance along the two sides up here. This part and this part. So we just find one part and times by 2. Alright, so the area of a circle is pi r squared. And then we're going to plus that by 2.1 times 2, that's 4.2. All right. Then someone use pi as 22/7. That's 22/7. The radius is 0.7 squared. We're going to plus back 4.2. Let's do some math.
Wait,
right, so
sir.
go ahead. Yeah, talk to me.
Sir, can you please zoom out?
Okay.
Sir, but the 0.7. Sir, that would not be the
Oh yeah.
the radius, so that'd be the diameter.
Yeah, half right. Thank you. Catch me again. Catch me again. Thank you very much. As soon as I say it, so me catch myself, you know. So the radius would have been 0.7 divided by 2, guys, is how much? You guys have a calculator?
0.35.
So 0.35.
Oh, sorry, you said 0.7 divided by 3?
2.
Oh.
So 0. Wait, what did you say, Alicia? 0.35 squared?
Yes,
okay.
sir.
All right, so do some math for me, please. What is 22 times 0.35 squared all divided by 7? Let's do this part first. We take our time because I've been making about 4 mistakes. That is quite unusual. We would find the circumference instead. See there, one next mistake again. Oh my God. Alicia, so we had the foolishness, you know?
Sir, yeah, I was just about to ask you why we're finding the area instead of the distance around.
It's because you see, what's throwing me off is I'm thinking about what I'm doing, and then I'm shading the thing, and because I'm shading it, my brain is telling me area. And then I'm not realizing that over here, I'm actually going around. So who was that kept me again? Antonia. So you see, whenever I'm shading this thing here, I'm thinking, but then I keep forgetting that I'm actually going around the edge. So it wasn't supposed to actually be area of circle. It was actually supposed to be circumference of circle. Yep. See, I'm goodly mislead all myself. So that's plus 2.1 times 2. All right, so the circumference now is 2 pi r. Thank you, Antonia. Good job. Plus 4.2. As it is 2 times 22/7. And the radius is, as Alisa says, divide the diameter of by 2. So that's 0.35 plus 4.2. All right, we're good now. I need to focus. Guess because I'm tired, I don't know. Maybe that. Or me I lose my skills. Which one? If you say me I lose my skills?
The tired man, sir.
I think so. I don't know. I don't want to doubt myself, you know. A joke. Okay, I doubt myself, man. It's tired, not true? I guess so. All right, so help me do some maths now, no? So what is 2 more? Can we double check? Because I make about 5 mistakes now, I'm not like this. All right. Me think me good. All right, so already now, what is 2 times 22 times 0.35 all divided by 7? Oh, I'm trying to say 2.2. So then this works out nicely to be what? 2.2 plus 4.2. So I get 6.4. Comfortable with that? All right, we're good enough, man. That's like a reason I go on this. Couple mistakes. I hope you guys see. I hope you guys see that mistakes is liable from anybody, you know. Especially if you don't get good rest, which means say, you think I should come tomorrow night? I'll leave you alone. I'm not gonna go and do nothing.
No, sir, you have to come.
Forward. You have to forward.
Happy forward.
You have to come,
Please,
sir.
sir, please.
Okay, I'll get some rest then and I'll be back. At the end of the class, we decide what we're going to do. At the end of the class, we decide what we're going to do. Are we going to do the pattern and sequence and make sure it's not good, or if you not don't alright with that, if you don't want to do something else for 2 hours, we will decide.
Pattern and sequence.
Yes,
We don't want
sir,
lock
pattern
it.
and sequence.
So no fully
And
lock
do
it yet
some
then.
more of the first questions as well.
Which for hold on, a 2 hour me ago now, you know. So now if you decide that one thing, we just want to lock off one question that gives you maximum marks. And sure. Sure, no,
Sir, how much the
pattern,
pattern and sequence normally value overall?
10 points.
And for question 1, it's normally 9 points, right?
Yeah, but question 1 kind of normal still.
Well, that's true.
Yeah,
Sir, do
question
the
1.
pattern.
All right, pattern and sequence. The chat is saying, Alisa said graph. Alisa have a full video on graph, you know. I have a full tutorial, like a full 3-hour tutorial on graph. All right, for now on, we do transformation.
I already watched those.
So which graph you talk? You're talking about transformation?
No, sir, not that one. Well, sir, minister.
Figure it out and tell me.
All
right.
Everybody said they understood the pattern and sequence and they will get 10 out of 10.
Yeah, so me don't know what they must say.
Exactly. The pattern and sequence is like the easiest thing. It's probably the only thing I'll get all marks for.
So you will have to decide from tonight, you know, when we close the class. You have to find a topic.
The pattern and sequence is just dependent on how you see the question. There is no telling if you're gonna get it or not, because everybody looks at it in a different way. Not everybody has the critical skills level to look at it and break it down in the way that Sir does.
Okay, so we're gonna just work with the pattern and sequence then and make sure everybody guarantee 10 points then. Moving on. Glenda uses the equipment to exercise 4 times a week and runs 9 kilometers per hour. Hold on, write this down, this is speed. For 20 minutes each time. Calculate the number of complete revolutions the running belt makes in 1 week during Glenda's routine. All right, we think you know. So Glenda uses the equipment to exercise 4 times a week and runs 9 kilometers runs at 9 kilometers per hour for 20 minutes. So we have the time, we have the speed, so we're probably looking for the distance that she run. So speed is equal to distance divided by time.
By time, yeah.
Based on what the information them give me, I'm just looking at what I have and what them possibly could ask me. So the speed is 9 kilometers per hour. The distance is unknown. And the time is 20 minutes. But because this is in kilometers per hour, you have to convert the 20 minutes to hours. So what is 20 minutes as represented as an hour? How much minutes make an hour?
60 minutes.
So break it down. 20 divided by 60 is what? Give me a decimal. Me work with a decimal. 0.33. All right. So therefore, fix up this nice and neat then. So 9 is equal to distance divided by 0.33. So cross multiply like what Cowan always do. When the unknown is at the top, multiply. So D is equal to, what is 9 multiplied by 0.33?
2.97.
2.97. All right. So that means that she run 2.97 kilometers. Not true. So that means for 20 minutes on the treadmill, she runs, because she run at that speed for 20 minutes, 2.97 kilometers every time she run. And it says that Glenda uses it 4 times per week. So that means that chances are they're saying that we should calculate the complete number of revolutions that the belt makes in 1 week during Glenda's exercise. All right, so hold on now. We have to go find out how much of the total distance. We're going to multiply this by 4 to find out what's the total distance we should run for the entire week. How much is that?
12.
So she run 12 kilometers for the 12 exactly?
Sir, I level
So I
point
used the fraction. I didn't use the decimal. I'm always told to use fraction.
Also use the fraction, so you get 12. 11 point change, and you get 12. Round it off. All right, cool. That's fine. 11.8812. Yeah, man. Use fraction. That is true because the 0.33 we would have left off a couple of the trees. We should have reduced our accuracy. So you're right, Alicia. 12. All right. So the number of revolutions. Now, a 3 marks. So it can't that easy. There has to be something more to it. We know that the distance around is what? What was the perimeter that we got around? The previous question. What was the perimeter that we got? 6.4?
6.4.
6.4 what? Centimeter, right?
Yes, sir.
So basically now we're going to divide this 6.4 into this 12, but we have to convert the 6.4
Sir,
centimeters.
it's meters.
It's meters? Oh yes, meters. Thank you, it's meters. So why do I have centimeter here? Thank you very much. So 2.1. So 2.1 meters. So therefore now we need to divide this 6.4 meters up here into the 12 kilometer, but we have to have them in the same unit. So therefore, we need to do that. Knock him down, man. Don't commit murder business again. And this, I'm only doing it this way for the persons who are not very skilled at doing it conversion in your head. So we're at meters and we're trying to get to kilometers. So for those who know, yes, you're going to divide by 1,000. Wonderful. So therefore, now we're looking at 6.4 divided by 1,000 will tell us the answer in kilometers. Talk to me. How much you got? Geneva, but aren't we converting from a small to a large? You said not divide. No, but up here we are convert, Geneva. We have the distance around the belt. All right, and in case I'm wrong, I'll take my correction. The distance around the belt here is 6.4 meters, correct? And we're trying to convert that 6.4 back to kilometer so we can divide it into the 12. That's our process is right? I think so. But you can't use the 12 kilometer. Why? Why we can't use the 12? Isn't that the amount of distance that she ran for the entire week? Isn't that what we calculated for the entire distance for the week?
She said you could, not can't.
Oh, I changed her distance to me. Oh, you changed the distance to me. But that can work too. If you want to do it the other way, no problem. If you want to convert the 12 kilometers back to meters and then divide it, no problem. At the same difference. All right, so we're going to convert the meters back to kilometers. So when you divide the 6.4 by 1,000, how much you get? How much you get, guys? 6.4 divided by 1,000. That's 0.064. I say go. 1, 2, 3, 0.064, yeah? 0.0064. 1, 2, 3. 0.0064. Right, good. So 0.0064. So 0.0064. So 0.0064 And then now this would represent the kilometer. So now, because we know say she run 12 kilometers for the entire week, I will now say 1 kilometer around the belt is actually 0.0064. You're gonna divide this into
Sorry,
it.
question.
Yeah.
Because my calculator is only showing me 0.064.
All right, let me take out mine and double check. Hold on. So 6.4 divided by 1,000. So 6.4 divided by 1,000. May I get 0.0064? All right, go ahead now and tell me how much you get for that now, guys. What is 12 divided by 0.0064? All right, so that's on. The number will come out sound good. 1,875 kilometer. 1,875 revolution. So that sound about right to me. That means that the treadmill thing, it goes around 1,875 times.
Sir.
Talk to me.
When I divide the 6.4 by 1,000, it'll show me 6.4 times 10.
Yeah, it'll give you a standard form.
Oh, you change that?
You know, say because of how your calculator program though. So you have to use that number there in your calculation. So how much you say you get?
6.4 times 10 to the power negative 3.
All right, so you see the negative 3 at least if you move 3 places backwards.
Okay.
Yeah, so if you want to do it that way there. All right, so Antonia, it's not 1,775. Sorry, it's not 1,875 kilometer. It's going to be 1,875 revolutions. Because the kilometer go cancel the kilometer, Antonia. Because remember, say this is kilometer, you know, and this is kilometer. So kilometer, I go cancel kilometer. And I left with just the revolution. All right. All right, and let's go critical thinking question. All right, so assume that the running bell moves at the same speed that gender, right? So we're good to go there, sir. And it's done. All right, some people might do it, some people might not. It's okay. It is what it is. So question 5 and question 4, are we out of here? All right, good. We are right. All right, let's go again. All right, so some grade 11 students were surveyed. Some grade 11 students were surveyed to determine the job sector in which they are most likely to seek employment after graduating. Their choices are represented on a pie chart shown below. We have something there, so cut up in some algebra and some degrees. All right, cool. We can see that. All of us can read that. Government is 4P, real estate is 2P, education is 3P, agriculture is 40.5 degrees, blah, and then 67.5 degrees. Cool. All right. It says calculate the keyword. So this have to be one keyword, percentage. So calculate the percentage of students who are likely to seek employment within the agriculture and ICT sectors. So and means you got to add them together. So let us get the percentage now. This year and this year. Add those two numbers for me, please. What is 40.5? So the and let me know so me have to add them together. What's the degree of that? 107?
108. 108 degrees.
Yeah, so I think it's going to be more than likely. It's going to be 108. What's the total degree of a circle?
360.
And a percentage we are looking for, so we're going to times it by what?
100.
Do the maths then, no? Do the maths. Asian brain. Do the maths, my people. Do the math.
30%.
Correct too. So the probability, or the percentage of students who are likely to seek employment within the agricultural and ICT sectors is 30%. 30% of them are choosing those employment within that sector. All right, cool. Next one, value of P, 3 heavy marks. So that means you have to think. The value of P. Now we know so the whole entire circle is what?
360 degrees.
360. So let's do some addition now. So we're going to add up everybody there, not true? And equate it to 360. So we're going to add 4P, 3P, and 2P. So 4P plus 3P plus 2P. And we're going to add, we already get them 2 here to be 108. So plus 108. Plus, don't forget the little 90 degree right here. 90 degree right there. And equate it to 360. So 4P plus 3P is 7P. 7P plus 2P is 9P. 108 plus 90 is 198. And that's equal to 360. So 9P is equal to 360 minus 198. 9P is equal to
162.
162. And then P I got equal to 162 divided by 9. How much you get?
18.
So once you get them nice numbers, you know what you think go float. We're nice, man. We're nice. Nice 3 marks this one. Nice 3 marks this one. Very nice, sweet 3 marks this one. So P then is equal to 162 divided by 9. P is equal to 18. All right, lovely. Done. Check, 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 check. Liz has a set of red, yellow, and white buttons in a sack. Give me a second, guys. Hold on. But like Latisha get kicked out of the class. Hold on, give me a sec. All right, so Liz has a set of red, yellow, and white buttons in a sack. She chooses a button at random. We want to know the probability that she chooses a yellow button. Sorry, the probability that she chooses a yellow button is 0.3. The probability that she chooses a white button is 0.1. We must calculate the probability that she chooses a red button. But that's not hard. Because maximum probability is 1. So the maximum, when something is sure, like you see, when you're gonna pick something out of a bag, and you're 100% sure. So when you put your hand in there, at that color they will come out, the probability is 100% or 1. But since as the probability is going to be for the yellow, it's 0.3. And the probability for white buttons is 0.1. Just add those probability and take it from 1. And we get the remaining probability. So 0.3 plus 0.1 is 0.4. So the probability is 0.6. And that's it. Marks them kind of heavy for this though, I'm not lie. I just feel like the question them worth like 1 point. And then I give you like 2. So the part here when
that's 3 marks for us.
Huh?
So it's a good thing. It's 3 marks for us.
Yeah, but then yes, Anthony, 0.6. But then it kind of throw me off because in my head, most of the time when I see a CSEC question that's worth 3 points, I know it requires some level of thinking. So I don't know. All right, they want to give it to us, we'll take it. We've been suffering all year, so we'll take it. All right, so last one here is if there were 80 buttons in the sack originally, determine the number of buttons that were red or yellow. or yellow. Red or yellow. Okay. Red or yellow. So probability, we know the probability, watch me now. Probability is equal to favorable over possible. And so we know that we're going to call it probability 1 and probability 2. So we're going to work out the probability of yellow and white, and then we can answer every other question after that. So the probability 1 is the amount of buttons for yellow. So since the probability of yellow is what? 0.3, and we don't know how much is in the bag, but we know that the possible amount of marbles in the bag is 80. What is 0.3 times 80? Because the unknown is at the top right here. So 0.3 times 80.
24.
So that says that 24 yellow was in the bag. So 24 yellow was in the bag. So 24 yellow was in the bag. All right, and then the probability of what now? White buttons is 0.1. So we know the probability again is equal to favorable but possible. So that's 0.1 is equal to F over P, F over 80. The unknown's at the top, so we multiply. What is 80 multiplied by 0.1?
8.
8. So that means say 8. So that means say 8 white buttons were in the bag. 8 white buttons. So therefore, by calculation, then we can confirm that the amount of buttons that was left for what? Red would have been 80 minus 24 plus 8. I could have done it another way, you know.
Question, why would never use the red that we calculated before?
Yeah, the 0.6, not true?
Because I did that, yeah.
Jaja. Take one long route. So 80 minus what? 32. Could I just use the 0.6 now? They just run up on them like headless chickens. How much you got? 48. All right.
40, yes, sir, 40.
40. So what they must say now is that if there were 80 buttons in the sack, determine the number of buttons that were red or yellow. So were red or yellow would have been 24 and 8. That's all. It says red or yellow. So does it mean that or?
But the 8 is white.
So it said, oh, sorry, wait a second. Red or yellow? Says red here. So it's red or yellow. So this is red and this is yellow. So it's going to be 48 and 24, not true? That's the answer. So we are running on a circle. Because let's use the 0.6, how we done, you know? And leave all of this extra stuff here. Maybe that will help some people, I don't know. All right, so I think that's it. That's it for that question. And now we have the last one before we get out of here. All right. I'm happy that I see this question too, because question attempts to throw up the students. So we see no circle theorem. Is this a sign? Oh, Alicia is saying 72 over 80. So what did you do? You added the let me see. I think maybe left off something again because Alicia is saying something. So them said them want if the 18 determine the number of buttons that were red or yellow. So you added the 24 to the 48 and get 72. Red plus yellow buttons, right? But the question is, when you put the 72 over 80, that's the probability, you know. Did they ask the probability? Them say if 80 buttons were in the sack originally. Determine the number of buttons that were red or yellow. I guess if you're right, 72 over 80 and write the answer, it won't hurt you. It won't hurt you. So I'm gonna write that 72 out of 80. All right. So good job, Alicia. All right, good. Last one. Must be tired now. A straight line L whose equation is 3x plus 2y equals c passes through the point negative 2, 8. Show that the value of c is 10. But that's not hard. Because if they give you the point right here, which is x, and they give you another point here, which is y, put x right also. I'll put 8 there so and see what happens. Let's see what happens. We don't know. Let's see what happens. 3 times negative 2 plus 2 times 8. That's negative 6 plus 16. Oh, that's easy. 10. All right. Wonderful. Yeah, man. So that's it. Determine the gradient of L. So the equation of the line works out to be what? 3x plus 2y equal 10. But to find the gradient is the number that is in front of x when you have it in the form y equal mx plus c. Good job, Antonia. So if the equation is in the form y equal mx plus c, any number that is in front of x.
So 3?
No, but in the form yet. You have to get it in the form y equal mx plus c first. So you have to get y to be by itself. So 3x plus 2y equal 10. Let us bring over the 3 here. And if it 2y equals negative 3x plus 10. And if we divide both sides by 2, y is equal to negative 3 over 2x plus 10 over 2. So therefore, y must be equal to negative 3 over 2x plus 5. Now it is in the form, Alicia, of y equals m x plus c. Therefore, my gradient is negative 3 over 2.
Sir, run back over that again there.
All right, so the first question says we must calculate c. So therefore, this incomplete equation here, we made it complete when we found c. So therefore, the equation that it was given to us was eventually this thing right here. Now remember that the equation of any line is y equal mx plus c. And when the equation is in the form y equal mx plus c, the number that is in front of x is your gradient. But like Alisa shows, she chose 3 initially. But choosing 3, the equation is not yet in the form y equal mx plus c. Y is not by itself. So y has to be by itself, Javari, before you can say what the gradient is. So by pushing the 3x over to the other side, I'm going to get 2y is equal to negative 3x plus 10. And by dividing by both sides by 2, I end up with y being alone. And when I divide by 2, you get something here down at the base, down here. So therefore then, looking at it now, since it's now in the form y equal mx plus c, we don't establish that any number that is in front of x is your gradient. And the number in front of x right here after the simplification is negative 3 over 2. So the gradient is negative 3 over 2.
What threw me up at that? Threw me think you'd find the LCM, that's why.
Oh no, man, we just want to get y by itself, man. We just want to get y by itself. Yeah, we just want to get y by itself. And look here to Javari. What if we take that point here, right? and I take this point, those two intersecting points, and I'll do the rise over run. Watch this. Rise over run. And the rise is what? 3 units. 1, 2, 3. And the run is 2. And because I'm rising downwards, it's -3, and I'm running to the right, so it's +2. So could I get the answer even one easier way? I wasn't even thinking like that, but I could have gotten it that way as well. So we could have used rise over run and get it right. All right, next one says the line with equation 3x plus 4y equals 8 intersects the line at the point T. Determine the coordinates of T. So basically then, this line right here, so, is crossing this line up here at T. Where do they intersect? This is a simultaneous equation. They can actually graph it. There's 2 ways I can do it. I'm going to do it both ways because I want to make sure you guys have something working with. So the first equation is 3x plus 2y equals 10. 3x plus 2y equals 10. And the second equation they gave us was what? 3x plus 4y equals 8. 3x plus 4y equals 8. Now, according to the principles of equation 1, equation 2, our objective is to try to get one of these variables the same. Either we get the y the same or the x the same. Now, in this case, since the x's are already the same, we can just go ahead and subtract. Once the signs are the same, remember, rule, same sign subtract, different signs add. So the signs of the 3's are the same, so we subtract. Subtracting that and that, we're going to get 0. 2y minus 4y is -2. And 10 minus 8 is 2.
I mean -2, sir.
2 take away 4, sir.
Yeah, but a positive.
2 take away 2 take away 4, sir. Remember, say it's 2 take away +4.
Oh, okay.
So that's 10 take away 8 is 2. And if you divide both sides by -2, we're going to get basically y is equal to -1. And if y is -1, just put it back into the equation up here, any one of them. So we're going to sub 1 for y in equation 1, any one. I use equation 1. So 3x, so we're going to have 3x plus 2 times 1 equals, equals 10.
Sir,
Yes, talk to me.
isn't it -1?
Oh, yes, you're right again. It is -1, and that would have thrown us off big time, you know. So divide by -2 here. It's -1 right here. So that's, thank you very much. 3x minus 2 equals 10. 3x equals, carry over that, we're going to get +2. So 10 plus 2 is 12. And then x are equal to 12 over 3. X equals 4. So basically the solutions to the equation are basically intersects at -1, 4. Sorry, nope, incorrect. It intersects at 4, -1. That's where it intersects. All right, so that takes care of that. I'm not going to show you the other way since I've gone there, so I'm a bit tired. Got some about 6 mistakes. It's more mistakes than I've ever made in a long, long time. So the diagram below shows the graph of L and 2 other lines, x equal -1. Let me highlight them lines up here, okay, you probably not see them. X equal -1 and y equal 5. So we can see the line y equal 5 here. And I can also see the line x equal -1 right here. All right, so good. What am I saying now? On the graph above, draw the line y equal. Oh, I can erase this now, not sure. Suppose I can erase that now. So then say on the graph above, you have to draw this line and shade the region that satisfies the inequality. Wow. So this line is already there. Let me give one little bit of linear programming here, so. They're making the paper quite balanced. They're not going too deep. They might touch every little thing. So that one is there. That one is there already. This one is there. So that this one we must draw. Now we know, so when we have a line y equal x minus 1, we know that when we want to find the x-intercept, y is 0. So for the x-intercept, y is 0. So 0 will go equal to x minus 1. Carry over the 1.
I'm having a hard time understanding what you're writing, even though you're saying it.
Okay, my bad. Let me write it a bit better. Lazy na Shamir. Alright, so we have y equals x minus 1. And we want to find the x-intercept. So if we want to find the x-intercept, y is 0. So we're going to put 0 right here. So 0 is equal to x minus 1. Carry over the negative 1. That means it's crossing the x-axis at 1. Now the same line again is y equals x minus 1. We want to find the y-intercept now. And we said x is equal to 0. So y must be equal to 0 minus 1. Y is equal to minus 1. So it's crossing the x-axis at 1 and crossing the y-axis at minus 1. Crossing the x-axis at 1, crossing the y-axis at minus 1. So that means it's going through here, 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 to do its thing, here. So therefore now the region that satisfies all 4 inequalities is this region right here in yellow. Right here, so. Right here, right here. That's the region that satisfies all inequalities. All right, that is the end of the paper. Was it a tough paper, by the way? Apart from a couple critical thinking questions, was that tough paper? Do you think that you guys could have gotten out of the whole entire paper now? Give it a good judge. If you had the chance to do this question and you would have gotten as much teaching as you got from me and from your other resources and stuff, let me see in the comments, how much out of 100 would you have acquired? Let's see what you guys think based on what you learned today. And you have to be honest with yourself. Out of 100, based on how much you remember you would have gotten and what you would have gotten wrong and gotten right, I have 35 persons in the chat. I'd love to hear from everybody. What do you think you guys would have gotten? Alexia, 50. One better than that, Alexia. Kerry said 50. That means you have to go work a little harder on the multiple choice. Gian says 64. 65 if my mind doesn't go blank. Ooh, 67. But the rest of people, them there. One little text message, Heinz says 59. Alisa says 75. All right. That's like one grade 1. Jalia says 100 out of 100. Wow. Brilliant. 66, 85, 50 or 60. All right, my people, them talk. So everybody in here look like them about 60 if I make good time. All right. That not bad. But now, guess what? No, the good news is that we know where we might possibly go wrong. All right, ladies and gentlemen, that brings us to the end of our 7th and final marathon. I trust that you guys enjoyed it. Even with the countless amount of mistakes I made today, I feel like I'm so tired, I'm so drained. But we have come to the end. We've come to the end. Tomorrow night, ladies and gentle folks, I'm coming from work about 2, get some rest, and then dinner on 60, 85, 30, 50, 70, 75. All right, so I'm coming from work. So I'll be here from 6. I could start from 5, but I think most persons probably don't get home until about 6. So I'm going to go 6 until 8:30. I'm going to give you 2.5 hours. That's it. 6 until 8:30. Yeah, I need to get some sleep, Jaya, for real. All right, so watch it now. Pattern and sequence seem as if everybody, that was most persons, not everybody, but most persons decision. So I need to know, confirm, so I can put together a little what you call it? A little document. Sadly. And then as soon as I'm finished with the class, I can upload it, Latisha. So maybe in the late night after you come home, maybe like in the midnight or so, you can catch what we did. So I'll upload it as soon as I do the class, I'll upload it. All right, so that is it, ladies and gentlemen. It was an absolute pleasure meeting some of you near and far. I trust that you guys enjoyed it, and I wish you all the very best on Tuesday. Make me proud. I believe in you. Make me proud. So I'll see you guys tomorrow at 6. Final touches. Oh yes, by the way, use this same link to enter the class tomorrow at 6. All right? And then we'll be back here with some pattern and sequence. And if I find anything interesting, I will bring it to your attention as well. All right? You all take care. Pick up on yourself and all the best. Have a good rest of day now. Bye-bye.
You too, sir.